let's go back to Algebra 1 and review a little bit of what you learned in factoring. Now, one of the most common mistakes with factoring that people always forget, myself included, is to always check for a greatest common factor first. It will typically make your factoring problems much easier or simpler if you just check for that first, and it's easy to forget to do that. For instance, in our first example, we have a binomial. We want to know what each term has in common, the greatest common factor between these. So we're going to start with the number. What's the biggest number that we can divide into 4 and 8? 4. What variable do they both have in common? They both have the letter A. The first term is a squared, the second term is just A. So they both have 1A. This one happens to have 2, but common. Remember, we're talking about what they have in common. They both have an A. So we're basically doing the reverse of the distributive property. We are factoring out a common factor, and what we leave behind in the parentheses is what would be left over if we were to divide it out. For example, if I divide by 4A, I would be left with A. 4A times A is 4A squared. If I were to divide out this common factor, I would be left with 2. So I have factored it. To factor just means to kind of undo the multiplication. We want to break it down into the pieces that multiply together to give me this polynomial. Right here, I can see that the biggest number that I can divide into 9 and 6 is 3. Forgot about my letters. They both have a factor of C. They both have 2 factors of D. But that's it. This one has 3 factors, but this one does not. And we write what they have in common. 3 times what is 9? 3 times 3. 3CD squared times what is 9CD squared? Just times 3. That's it. We're already there. 3CD squared times what gives me negative 6CD cubed? Well, I would need negative 2. 3 times negative 2 is negative 6. C is already there. D needs to multiply by a factor of D squared and needs to multiply by a factor of D to get back to D cubed. Sometimes there's not going to be a greatest common factor. Notice between x squared, 5x, and 6, there's not a number that I can divide out. There's not a common factor. They don't all have a factor of x. When that happens, we're going to have to use a different method. We're going to take this leading coefficient, which in this case is 1, and multiply it by 6. And write it off to the side. Now I'm going to list my factors of 6. 1 and 6, 2 and 3. I'm looking for a combination over here that combines to give me 5. 2 and 3 gives me 5. 6 take away 1 also gives me 5, but this is not a negative 1. This is a positive 1. So this is my winning combination. I'm going to put that into my parentheses. We're basically unfoiling this. We're breaking it down into the 2 binomials that it used to be before we multiplied them together to get this trinomial. So I would have an x, a positive 2, and a positive 3. And if you check it, you can box it. X plus 2, x plus 3 gives me x squared plus 2x plus 3x plus 6. When I put those together, x squared plus 5x plus 6. I get back to what I started with. Let's try another one. 1 times 12. So I'm looking for factors of 12. 1 and 12, 2 and 6, 3 and 4. Notice I have all my factors because the next number would be 4 and 3, but it's already on the list. So once you've made a complete loop You can stop looking for factors. Now we're looking for factors that combine to give me -8. None of these combine to give me -8. This comes the closest because it gives me 8, but it doesn't give me -8. Remember, when we're looking at a polynomial, the coefficient of the x squared term is a, the coefficient of the x term is b, and the constant is referred to as c. So when the constant is positive, the factors that we're looking for are either both positive or both negative. So both positive is not getting me to this -b, so I'm going to make them both negative. You see that -2 times -6 is still +12. But when I combine them, I get -8. So these are my factors that I'm going to put into the parentheses. X, take away 2, x, take away 6. Again, if you FOIL it or box it, you will get x squared minus 8x plus 12. Let's take a look at what happens when AC is negative. When C is negative, we have -15. I'm writing my factors, 1 and 15. 2 doesn't work, 3 and 5, 4 doesn't work, 5 is already on the list. I have all my factors. But remember, to get a negative when I multiply these, one of them has to be negative. So when C is negative, there will be one positive and one negative factor. X plus and X minus. Now we need to look at the sign of B to decide which number is going to be the positive one and which one's going to be the negative one. I'm trying to get a positive 14. Positive, that means the larger number is going to be positive. I want to keep my big numbers positive and my little numbers negative. Do any of these combine to give me 14? -1 and 5 does make 14, so we have a winner. I'm going to put my positive 15 here and -1 right here. If you were to check this by multiplying, you would get x squared. 15x minus 1x is 14x minus 15. What happens when this coefficient isn't 1? Well, I'm still going to multiply just like I did before, but my answer isn't going to be -3. Now it's going to be -18. Let's list factors of 18. 1 and 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, 6 times 3 is already on my list. I need one column to be negative. The positive is the B, so my big numbers are positive. I'm going to make these negative. Do any of these combine to give me 7? Yes, this is my winning combination. Now, before, we simply drop them into these parentheses next to the x. We can't do that now. Because of this leading coefficient, we have to pay for it. In order to do that, I'm going to write that leading coefficient and put an x with it and put these winning combinations underneath them. So I'm going to put a -2 and a 9. And now we reduce. I can divide both of those by 2 and I get a 3 and a -1. I can divide both of those by 3 and I get a 2 and a 3. These are now my reduced factors. 3x -1. 2x +3. Go ahead and check it by boxing it. We have 3x, -1, 2x, +3. That gives 6x squared negative 2x, 9x, and negative 3, which these combine to give me 6x squared, 7x, take away 3. So I know it works. Again, something I should have done on the last problem, but I didn't, is check for the greatest common factor first. Always want to be checking for that greatest common factor. Is there something that I can divide each term by? Well, all numbers are even. I could divide each of these by a 2. So I'm going to do that first. I'm going to factor out a 2, and I'm left with 3x squared minus 25x. Divide that by 2 gives me plus 8. Now all I have to do is factor what's left. So I'm going to take that off to the side. 3x squared, take away 25x, add 8. I'm going to factor this. 3 times 8 makes 24. Factors of 24 would be 1 and 24, 2 and 12, and 8, 4 and 6, 5 doesn't work, 6 and 4 is already on my list, so I'm finished making the list. I can't combine any of these to get a negative 25 without making all of these negative. Remember, if this number's positive, both columns are positive, both columns are negative. It's the only way to multiply to get a positive number. Now I see my winning combination here. I'm going to put my A value, my leading coefficient, put my winning combination beneath each one, and reduce. This does not reduce. This will reduce. So I end up with 3x minus 1, x minus 8. That is what this portion equals. So for my final answer, I drop down the 2, I write 3x minus 1, I write x minus 8. That is my fully factored answer. Don't forget that factor of 2 when it's asking for a complete factorization. Alright, greatest common factor. They don't have anything in common. It's not a trinomial, but I could make it a trinomial. I could say x squared plus no x minus 49. That's the same thing. So now I take 1 times negative 49, which would be 1 and 49, 2, 3, 4, 5, 6, 7, and 7. I need one column to be negative, so they multiply to give me a negative 49, and I want them to combine to give me nothing. So 7 and 7. X minus 7, x plus 7. Over here, is there something common? Oh, I can divide both of those by 3, which gives me 9b to the 4th minus 25. 9b to the 4th plus, this one's a little more complicated, isn't it? Let's go back and look at a pattern here. Notice that x squared is a perfect square. It's x times x. 49 is also a perfect square. It's 7 times 7. When you have a difference of squares, meaning two numbers that are perfect squares subtracted, you can simply use a formula, which can be found right down here. So we should always be checking for that. After we've looked for our greatest common factor, check and see, are we dealing with perfect squares? Is there something I can multiply by itself to get 9b to the 4th? Yes, 3b squared. If I multiply it by itself, I get 9 9b to the 4th. So this is a perfect square. How about 25? That's just going to be 5 times 5. That is also a perfect square. And I have subtraction here. Now, if this was a plus, I couldn't do this process. It has to be subtraction. And the rule is, you simply write the square root first of the first term. Square root of the first term. Square root of the second term. One is positive, one is negative. My GCF drops down for my final answer. That works every time that you have a perfect square. It's important to know what the perfect squares are. So perhaps you should put this in your notes as well. These are just the first few perfect squares that are very common. This is 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Be on the lookout for these special numbers. These are perfect squares. Additionally, we also have a special formula when we have the sum of two cubes, or the difference of two cubes. Let's take a look at what that would look like. Y to the third is a perfect cube. It's y times y times y. 125 is also a perfect cube. It's 5 times 5 times 5. So applying the formula, we just write the cube roots and keep that same sign. Then we're going to square the first term. Y squared is y squared. We're going to square the last term. Negative 5 times negative 5 is 25. And in the middle, we're going to multiply them and change the sign. So y times negative 5 is negative 5y. Change the sign. If you were to put this into a box to check it, it would come out as what we started with. Let me show you. We get y cubed, 5y squared, 25y, negative 5y squared, negative 25y, and negative 125. These cancel. I'm left with y cubed minus 125, so I know that I factored it correctly. Here we have a sum of perfect cubes. I know it's a perfect cube because m is cubed, 8 is a perfect cube, it's 2 times 2 times 2, 27 is a perfect cube, it's 3 times 3 times 3. I'm going to write the cube roots with the same sign. Then I'm going to square the first term, 2m times 2m. I want to square this and get 4m squared. And then I want to square my last term as well. 3 squared makes 9. Then I multiply them together and change the sign. 2m times 3 is 6m. Change the sign. That's a good way to apply these formulas without having to memorize them. And again, when we're talking about perfect cubes, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. These are some very common perfect cubes to be on the lookout for. Be careful with 64 because that's also a perfect square. That can get a little tricky. All right. If you look at this chart that I have here, we've factored by using a greatest common factor. We used some special formulas. We've factored general trinomials that have 3 terms. But what happens when there's 4 or more terms? That's when we need to use grouping. Notice in this next example, there's not one number that I can divide all 4 terms by. I can't divide them by 2, I can't divide them by 5. There's not a number. They don't all have an x. When this happens, we just need to group them together. I'm going to take my first 2 terms and group them together, and I'm going to group my last 2 terms together. I'm going to use some grouping symbols of parentheses. Now I'm going to use the Gcf method. I'm going to look at these first 2 terms that are yellow and say, what do they have in common that I could factor out? Well, they both have an x squared. They both have 2 x's, so I'm going to pull out an x squared and write what's left behind. You can just ignore this part over here right now. We're not even looking at the blue parentheses, we're just looking at the yellow. X squared times x is x cubed. X squared times 5 is 5x squared. Now I'm going to do the same thing with my blue parentheses. Negative 2x and negative 10 are talking. What do they have in common? Well, they're both negative. Ugh. And they can both be divided by 2. They're both even. Do they both have an x? No. This one has an x, this one does not. This is all they have in common. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. Well, look what happened here. When I did the GCF to each group, and I applied that factoring principle, I now have a common factor in each in the form of a binomial. So now I'm going to pull that common factor out and write it out front. Then I'm going to put some parentheses and write what's left behind. What's left behind? X squared, take away 2. So this is our GCF binomial, and this is what's left behind. Let's try it again. I'm going to group my first 2 terms. I'm going to group my last 2 terms. Use some color again. Color helps me see things best. In the yellow parentheses, what do they have in common? They don't have a common number. A, they both have an A. Y, nope, they don't both have a Y. That's all they have in common is an A. A times A gives me A squared. A times 3Y gives me 3AY. Alright, that takes care of the yellow parentheses. How about the blue parentheses? What do they have in common? Well, they're both even. I can divide them by 2. That's the biggest number. They're both positive. They don't both have an A. This one has 2 Y's. This one has 3 Y's. So they both have 2 Y's. What's left behind? 2y squared times what is 2ay squared? A. 2y squared times A is 2ay squared. 2y squared times what is 6y cubed? Well, 2 times 3 gets me to the 6. Y squared needs to multiply by a y to become y cubed. I've got it. And look what we have. We have another common binomial. I'm going to write that binomial first, a plus 3y. Then I'm going to write what's left behind in the leftover parentheses. A plus 2y squared. And I'm finished. And if I were to box this just to check it, to to make sure I get the same thing that I started with. That's always good to do, especially when you're new to factoring by grouping. A squared, 3ay, 2ay squared, 6y cubed. Notice I get a squared, 3ay, 2ay squared, plus 6y cubed. So I know that this has been properly factored because when I multiply it, I get back to my original answer.